Okay, going to have our last talk of the session now from Adam Forys and Magdalena Krochmal from Roche, who are going to talk about mastering Plumber structure, your API solutions.
All right, hello everybody. Nice to see you, a lot of you attending this session. So once again, my name is Magda. With me today, Adam, and we'll be sharing some secrets on mastering Plumber APIs. So just a little bit of organization. We'll first introduce basic what API is and what Plumber is, and then we'll dive deep into how to create your basic Plumber API and then how to make it better, deep diving into the code, creating Plumber as code or Plumber as a package. A bit about the performance if we have time, and just to wrap up, which Plumber API should you use for your specific use case, if you're starting with R or you're super advanced. So API, it stands for Application Programming Interface, and it's a channel between a client and a server, so a ways of communicating. And we often illustrate it as a waiter that would come and take your order, and then this order, which is a request, would be then forwarded to the chef at the restaurant. So the chef would take care of preparing your meal, and then the meal comes back to the waiter, and as a response, your dish is back to you, so you can enjoy it at the restaurant. So that would be the very basic way of describing what API does, is this middleman serving your dish. Moving on, we have different types of APIs, and in general, you could imagine an application of trying to expose some data, let it be from a database, so you don't want to give all the users' credential to access the data, but you want to expose it, so APIs is there to help. Or you do some kind of processing of the data on the server side, and you want to return the output. So you can let users access the API directly, or you can also have it accessed by some kind of API, so you can build mobile APIs and so on to show your data and expose what the API is doing. And just a couple of everyday examples. So if you ever search for a doctor and you see the map on their website, chances are this is the Google Maps API showing there, and a couple of more examples of your daily life that you might not know that there's an API behind, but in fact there is. So they are really everywhere, and this is kind of a universal way of sharing the information and having this communication channel between some source and your API application. So now going into Plumber, so the fun part. So Plumber is an R package and also a framework for creating APIs. And what is magical about it, it's so easy to expose your R code and show it to the world by creating an API. And here I have just a quick start code. And if you're a quick copy paster, then you can really create your local instance of the application just like that. So I have the plumber.r here presented. As you can see, it looks kind of like an R function. So we have this Roxygen-like comments that would help you name your endpoint. This is how we call those different small functions that you have in your API. And then a couple of parameters that you can get. You can also declare what kind of endpoint it is. So if it's a get, put, and so on, depending on an action that you want to describe. And of course, function is what the core is, so what do you want to do, what kind of processing is there in the application. So with this plumber.r file, all you have to do is call the PR function, and then here you go, you have your local instance of the API showing. So I have a small GIF illustrating that, so you see you get this Swagger API out of the box. You can already try it. You will see for this specific example, you just type a message, and what the API is doing is showing you, hello user, the message. You can see curl and request URL showing up. So this is normally how you would refer to the endpoint in your application if you want to read the final output, which would be some kind of a JSON file, for example, that you would show to the users, or any type of data that we would be requesting for. So about the deployment and hosting, so in your organizations you might have the POSIT server, so that's the easiest way, I guess, to deploy any kind of Plumber API. What you have to do is just declare in options in RStudio your publishing account, and then with this small I in your Plumber R script, you just publish your API, and voila, it's there for everybody else to access. Of course, you can limit this access and all the specifics. You can also use any kind of other services. So on Plumber website, I saw the DigitalOcean. You can also have some kind of container as a service or Docker. But it's really easy to just get your API out there for everybody to use. So now, going into the interesting parts of the actual code, how many different structures of Plumber do you know? 0, 1, 2, 3. Don't worry, we'll introduce all of them now. So here we go. The very basic one, as I already mentioned in the quick start, is this plumber.r file. So you don't need much. You need just your kind of R functions with some of the decorators to declare different kind of endpoints. What's great about this, it's so easy to create. So you could see in just one click, I have the API created and working. So for any type of beginner in the applications, that's the best way to start. What's also great about it, web is full of the examples. So already with those kind of markdown information, you can do a lot. So you can have a really nice basic API working. So yeah, the best way to start. And if your app is not really complex, then yeah, why bother creating something more? So me, I'm personally not the biggest fan of Shiny, sorry, but whenever I can cut short and just expose the data in not very pretty format, but doable for users, then I would just create a quick Plumber API and not really bother creating Shiny and making my table beautiful, for example. And then disadvantages, so this kind of code that is in Plumber.r is not really easy to test. I guess that's one of the limitations. And if your API gets complex, you will notice that, okay, maybe those tags don't have all the features I would like to have. And then you run into the problem of, okay, what should I do next? And we will talk about this. So you'll have to go deeper into the PR object and how to modify it in order to make things happen. So you can really extend a lot, but the basic structure is there. So just a couple of best use scenarios, as I said, very easy applications with low complexity, building POCs, so just a few clicks and you can have your function ready and exposed to the users, or data from the database shown to the users, if you will. And if you're not experienced with Plumber, this is a great way to start and build upon your knowledge. So as I mentioned, things can get complex and you might want to explore more and be stuck at some point saying, oh, okay, these tags don't do enough for me. And then what you have to do is open the PR object and explore that logic. And now I'll let Adam talk about that.
Yeah, thank you, Magda. So let's go a little bit more into the technical details. So the Plumber allows you to modify the Plumber object. So this is like the Plumber object, and there's two different ways of doing that. We can do this in the plumber.r file and just through the special function, or we can be responsible for creating the Plumber object with the entry point file. So this is like two ways of doing that. But what actually is the Plumber object? So the Plumber object is just a R6 class, and I really love this approach because you can like do whatever you want with that. You can print everything what is in the Plumber class, and this is the representation of the API. So this representation is just trigger and run in the runtime of the Plumber. Yeah. So to summarize, like this approach, we can have the Plumber file and the entry point, where we can, this approach allows for more customization. So we can play with this Plumber object and do actually whatever we want. So let's move to another approach. Whoa, have you know about that? That you can create the Plumber API as a code. So actually on the right side, you see the Plumber file, the representation of it, and exactly the same thing you can achieve using like the Plumber function. So the Plumber follows the functional paradigm and programming paradigm, and you can use all the Plumber function to create this object specification. So play with this like Plumber object. And you can use all this function that should allow you to like cover most of the things with the Plumber. But actually, it shouldn't stop you from direct interaction with the Plumber object. So you can directly interact with the R6 class. But if you are not happy with everything what the Plumber provides, like all the hooks and how the API works, there is also possibility to extend Plumber class. So this is more advanced technique, but you can also do this with Plumber, because Plumber is a R6 class. So actually do whatever you want. If you, for example, want to hide the endpoint in the Open API specification, you can do this. And this is really easy. So to summarize, you don't need to have the Plumber R file. You can do everything in the entry point.r. So you can just create your Plumber API as a code. But yeah, this is not the end of the structure that we have. So wow, you can build your Plumber API as a package. So you can actually pack everything what contain the business logic. You can pack this into the R directory and follow the standard package development process for R. And the Plumber definition can just be stored in the inst directory as a Plumber. But why it's important? So when we're developing Plumber as a package, we can use all the community dev tools, like the coverage, test that, Roxigen, package down. It's really nice from the perspective of testing or just to follow the good practices of the R package development. So it's not the only benefit that we get. One of it is, for example, description file that can contain more information about your Plumber API, but also you can manage the dependency of the product, of the API that you're working on. It's, for example, really convenient when you're deploying the API to the POSIT Connect, because all of this is going into the manifest file that is processed on the POSIT Connect server. So in my opinion, it's really convenient. So the Plumber itself have the built-in functionality where the Plumber can be stored in this inst directory. So you have a lot of different functions in Plumber that allow you to source and, for example, get available APIs. And as you can see in the Plumber package, there is a lot of examples that could be used and you can play with. So you can just plumb them and get this definition and run this definition in Plumber. So wow, you can zip your Plumber into the package. So it's a really nice approach because you can also benefit from the CI/CD integration. I think this is really crucial because there is a lot of different extensions that you can use for GitHub Action or for GitLab CI, and you will get this for free because you decide to just pack everything into the R package. So yeah, so we can also combine this method. So if you can build Plumber as a code, you can also build a package from it. So this is in my opinion, it's a really nice approach because you can actually create the code that will be preparing this Plumber structure, this Plumber definition, and it can be just trigger in there to run it. And there is a lot of possibilities to also extend this functionality. So for example, you can add the multi-environment support that, for example, allow you to decide on which environment what will be showed or which endpoint will be available on which environment. And one of the really nice approach is also applying the custom decorator. So what is decorator? So in simple word, the decorator is the function that changing the behavior of another function. So if we do not want to complicate the existing logic, the business logic, and do not want to adding extra code to the function that we already have, or for example, we migrate from one Plumber structure to another Plumber structure, we can do this using the decorator. This is really advanced technique, but actually something like that is possible because we can just apply to the slow function, we can apply decorator that for a specific environment, for example, only for the production, will add the promise evaluation. So it will be parallel computed for the Plumber. So I really enhance everyone to consider using this technique for improve the quality of the package because you can separately test the slow function, and also you can be convenient that this promise decorator do what he needs to do. So separate test without combining the logic together. Otherwise, for example, this future promise needs to be added to any different function that's used in this Plumber API. So to summarize this, in my opinion, the best approach, we can just using all the benefits from the R package development and also write everything as a code. So this is also in our case, we work in Roche and we need to validate our product. So it's perfect for validation because we just passing the Plumber API as a package into the validation team. Of course, it's also require a lot of R experience, but it's usually coming with the time when you develop this. And in my opinion, this is also the universal framework that you can follow not only for Plumber, but also for different packages. For example, in Shiny follow this concept as Shiny as a package, that it's really used from the long time. And in my opinion, it's one of the best approach. But we don't want to force anything. As you heard on yesterday keynote, in R you can do whatever you want. And to summarize, I will pass my voice to Magda.
Thanks a lot. All right, so which approach should you use when you're creating your API with Plumber? Yeah, starting with the very basic. If your app is complex, then you'll have to do more advanced techniques, and live will show you that you'll have to advance from the basic structure to advanced one, of course. But if you're just a beginner, want to try APIs with Plumber, then just start with the plumber.r file and see for yourself. And I guess once you try, you will start seeing even more possibilities and where you could create API and different use cases. That was also my case. And of course, as you're advancing, you will try to start to realize, okay, maybe that's not the optimal way. Maybe I need to validate some of my code. Maybe I should have it as a package. So you slowly progress into this Plumber as a code or Plumber as a package. And of course, later on, thinking about the performance also, you might start to use decorators. Like Adam mentioned, this future promise evaluation is amazing when it comes to scaling our application for multiple users, different environments, and so on. So start simple if you have a simple use case, and then life will show you if you have to advance or not in your Plumber journey. Then just sharing a couple of resources. So we presented a couple of templates, starting from very basic plumbers to those plumbers as a code as a package. Those are all available in the GitHub repository, so feel free to check them out. Inspiration for this talk was kind of our application of the Plumber API building Mint Plus package. We have a poster about that, so visit us if you have more questions about Plumber or the project in general. But this is where we also started very basic and then had to build the application, which is now amazing. But we went through all the stages, ending up with Plumber as a package. So to make life easier, to make it easier to validate and ready for the pharma purposes. Then what more about Mint Plus, we also had a virtual talk, so you can also check that out to learn more about the SDTM automation space and how we used R for those different purposes, including Plumber APIs. Then just encourage you to learn more about R6 class. We already heard it's amazing for Shiny applications. Also in Plumber we use R6 class, and yeah, it's proven very effective, so why not explore it? And you're welcome to visit Plumber website to learn more about the code and kickstart your journey in the application world. So thanks a lot for your attention. If there are any questions.
Thank you. So we've got time for at least one question, if anyone has one.
Thanks for your talk. I have a question concerning the authentication and authorization. You told that there is a possibility to do that. How do you solve that problem or at Roche?
So mainly we're using deposit product. So for Plumber, it's super easy because you just require the user to log in, and in the header you getting the user credential. And in our case, it looks like the Plumber API have the special function that it's checking if the user is authenticated and getting this information back about who is the user, getting like Unix ID exactly.
So as we also said, there's no limits to that, and also in our applications, even though it's inside the Roche network, we have this API key implemented, so it's not like any users can come and trigger any actions. We have the key that is a secret, and it has to be provided in some of the endpoints that are, for example, making the writes to the database. So we can easily implement that on the Plumber in the PR function object.
Okay, oh well, we've got a break now, so.
Is Plumber has any feature to avoid cyber attack, or is there any security feature of it? Well, for example, I try to use the API continuously.
So nothing what I know about, but you can implement this by yourself. So like in Plumber, allow you to, for example, create the filter function that you can like define the logic. Yeah, for example, apply some rate limits for this for specific IP address, or it really depends from the developer. So this is more like a framework, but yeah, I do not know any existing implementation of it as a separate package. But maybe it's a good point to start something and write some open source that can, for example, like create the rate limit for the Plumber API. Yeah.
So thanks again to Adam and Magda and all our speakers.
Thank you.
Thank you.